Chris Brault. I've been involved with the weather since, since I was little. On September 27, 1985, I was 4 years old. Living in Bridgeport, Connecticut at the time, and Hurricane Gloria came up the shoreline and slammed into New York City. And it changed my life forever. I just celebrated my 25th anniversary with weather. We've had a glorious run so far. We're still together, having a great time. So it's been a lot of fun. But I'm glad that I'm here. I'm with all you guys and talking about the weather. So let's get down to business and talk about St. Louis. The Weather Service, or Weather Bureau as it was called, began in 1870. Can anybody tell me who was the acting president in 1870 who began the Weather Bureau?
Grant.
You are correct. Nice job. Did you use your iPhone to find the answer?
No, this is all I got when I turn my iPhone on.
Oh, a dog. Please. Anyways, so, yes, Grant took the Signal Corps and created the Weather Bureau under the Department of Agriculture. Now, St. Louis has been doing weather observations for a very long time. Like Ben Franklin's been doing them the longest since he came to America, way in the 1700s. But there's been a plethora of instruments. There's been no standardization, and we were doing we were using different instrumentation and taking measurements in downtown St. Louis from 1830, 1870. With the standardization, it created localized sites for different points of America. And what's really cool is, who's been to the Smithsonian? Has anybody been there? Okay, Smithsonian kind of began a little bit with the Weather Bureau. What happened was, when the Weather Bureau and the Signal Corps merged together and you had these individual sites, they would telegraph out their observations to the Smithsonian. So at the Smithsonian, they had this huge map wall that they would put the observations up upon hourly. That is the very first map analysis of the United States, was at the Smithsonian. Really cool. The map wall, if I remember when I was a kid, is still there, but I could be mistaken. It might be gone by now. I know the Smithsonian has undergone a lot of changes and renovations. So anyways, in 1870, we did not have an office. We were an observation site. No one was doing forecasts at the time. And we come years and years and decades later, things happen, events happen, and so on. And we get aviation consideration thrown into the mix, 20s and 30s. Lambert Field came around that time. So finally we had, in the beginning of 1930, we had an observation station downtown and another one out at Lambert Field. So downtown we have ones of like 8th Street, Locust, Washington, you name it, they were moving all over the place. They moved from the postmaster's office to an agricultural building. It was just flip-flopping everywhere. With post-World War II, and the realization, I was telling another group earlier, you know, during World War II, when we sent bombers to Japan, they kept running into a headwind and they didn't know what it was. Well, it was the jet stream. And that's how analysis, you know, having weather forecast offices and stations and upper air balloons, that's how it all kind of began. It's just kind of like you learn a lesson. You know, it's kind of getting slapped on the wrist, you learn your lesson, and you do something better out of it. So here's what we have. And when Lambert came around, and in the post-World War II era, under the Eisenhower and into the Kennedy administration, we started doing weather forecasts. You know, there were tornadoes that were happening across Oklahoma in the late 40s, and that's where the first tornado forecast was ever made. The first tornado warning was ever issued was at, what's the base, Whiteman Air Force Base down there? I can't remember.
Down in where? Oklahoma?
Down in, yeah, like Oklahoma City, Norman area.
That's Tinker.
Tinker. Tinker is where the very first tornado warning was ever issued. They had a tornado the day before, and the next day they said, you know what, the weather conditions are the same, we're probably going to get a tornado again, and once you know it, they got hit by a tornado the next day, that day. So that was the very first tornado warning, tornado forecast. So weather forecast offices started coming around in the early 50s, and the first one for us here in St. Louis was out at Lambert. So we had a weather forecast office out there that lasted until about 1974. It's unclear if there was a radar out there, but in 1974 we moved to the St. Peter's location. Does everybody know where that's at? It's at Cave Springs at Mexico and Youngerman.
Oh, yeah.
And there is the old building with the radar, which I believe is a WSR 74, but maybe an old 57 that's been retrofitted. I'm not absolutely sure. I have to ask one of my guys. I keep getting confused. So the radar is not there anymore, but the old radome is. So at that time, we were forecasting from the 50s to 1991 when we came here. We forecasted for the entire state of Missouri. During the Carter, Reagan, Bush administrations, there was an essential need to improving the coverage of radar. We had like the April 3rd, 1974 super outbreak of tornadoes across much of the United States. That was a big lesson learned. There were multiple other lessons learned, but we really needed better spatial coverage of radars. So the WSR-88D went through about 20 to 30 years of implementation, and by the early 90s, it finally was put into what is called modernization of the National Weather Service. So our office, which controlled all of Missouri, was broken down into smaller offices like Springfield, Missouri, and Kansas City, Missouri. There's ones in Memphis and Lincoln, Illinois, etc. But with each office, there was a radar associated with it. So every office would have a localization for a particular area for which the radar would cover. So the radar can usually cover out to 250 miles, but by the time you're 250 miles out, you're about 10,000 feet off the ground. So they kept the distance roughly about anywhere around 150 miles for every weather forecast office. Because that's really the range of the radar where you can still see the low levels, you can look and see tornado circulations, analyze the column of the atmosphere pretty effectively. And so that's where we've been since 1991 with our WSR-88D out there. We've been analyzing the atmosphere, producing forecasts that are tailored to the local area, which is really, really nice. We're going to hopefully get some more upgrades. We've gone through massive technological and significant upgrades since our inception here in 1991 with computers and so on. And then 2 years from now, we're hoping to get dual polarization, which will improve rainfall rate estimates from radar. That will improve, hopefully, our flash flood forecasting, because flash floods are probably the biggest killer in all of, mainly the Midwest, I would say, over tornadoes and lightning combined.
Well,
Floods
anything
really
to do with snowfall?
Yeah, it'll probably improve snowfall and measurements, not so much how much is on the ground, but really dual polarization. What it's meant to do is rain falls in different shapes and sizes. This new dual polarization, which is like a beam of a wavelength goes like this, and then another one goes like that. So it's complicated, but it's better. It can ascertain the shape of the drop. By ascertaining the shape of the drop, it can ascertain how much of those types of drops are falling, which gives us a better rainfall rate. So it does work pretty well with snowfall crystals, but again, snow is it's ice, it's prismy, sometimes it's very erratic, otherwise sometimes it's a really nice flake, like a dendritic flake, which has nice size, equal size, etc. So it'll be interesting to see what happens. 20, 30 years down the road, hopefully you'll get phased array radar. And that would be really nice because the volume scan for a radar is about 5 minutes during a severe weather episode. And you know, if a tornado touches down, that first minute of the volume scan, we're not going to see it until 5 minutes later if it's even still on the ground. So the phased array radar rotates about 2 to 3 minutes per volume scan, which would not only have better, it also has higher resolution, but it would improve our spatial and temporal resolution. So it's really nice. Looking forward to that.
Well, the military already has that.
Yeah, that's right.
But it's so expensive, top secret. Don't ask us about it.
We're testing it. If you
Now we
guys
have to
want,
kill you.
if you guys want, jump on Google.
Phased array radar.
If you
Instead
guys,
of the big.
well, I was going to say, if you guys want, go jump on Google, type in phased array radar in University of Oklahoma. There's a test bed radar down there that's looked at cases with tornadoes, etc. So, okay.
Excuse me, you guys want to